Swapping engines is complex due to variations in equipment and accessories between cars. Many combinations exist, and it's difficult to predict compatibility until installation. Components like pulleys, AC compressors, dampeners, radiators, headers, ignition coils, and more may not fit as expected. A Caprice PPV L77 is not really an LS. L77 is a police car version of the L76 engine. L77 parts are more expensive. The L77 engine was imported from Australia. Holden Commodore. Don't believe me? Go to AutoZone and start asking for parts for this car. Let's talk about aftermarket parts. Engine mounts, transmission cross members, and peripheral equipment are now readily available and relatively inexpensive. Installing newer GM technology. This requires specialized knowledge and expertise. The performance package must be compatible with the F-body chassis. Components like the engine, suspension, brakes, wheels, and tires need to be compatible at the minimum and ideally complementary at the maximum for optimal performance. Now let's talk about features of modern engine technology. The LS engine incorporated advanced engineering and design for its time. Traditional pushrod valve train. Despite being a modern engine, it retained a traditional pushrod valve train design. Class-leading performance and fuel efficiency. The LS engines were known for their impressive power output and fuel economy. The significance? It replaced the defunct LT1 and LT4 engines. The LS series replaced the older LT1 and LT4 engines, making a new era in GM's engine development. Flagship vehicle, the 1997 Corvette was the first vehicle to feature the LS engine, showcasing its potential and setting a new standard for performance in GM's lineup. When installing engine mount brackets, don't tighten the bolts. These engine mounts bolt to the subframe. Give yourself some wiggle room. Come back and tighten them after. Make a list of what you need: engine mounts, adapter plates, transmission crossmember, headers, oil pan. Work smarter, not harder. Compatible parts from the same manufacturer are easier to install. Experienced swappers can mix and match parts, but this slows the process down. Prevent damaging your engine. A must-have when you don't have the front sheet metal, fenders, front fascia, grille removed. A load balancer is helpful when installing an engine and tranny together. Makes it easier when installing the engine on the frame rails. Remove the front sheet metal clip so you don't damage anything. Most LS swaps don't require any modification to the transmission tunnel, except for the shifter access hole. Many first and second generation F-body cars have similar specifications. Tolerances can vary between different car bodies. The 4L80E and the 6L80 transmissions, for example, do not need any transmission tunnel adjustment. First things first, remove the hood. Remove the 4 bolts and you're done. Remove the hinges for easy access to all the fender bolts. Bag and tag. It's crucial to keep all the bolts, clips, shims, and spacers in a bag and labeling them so you can easily reassemble things later. Keep track of your fender shims. Some bolts have more than one shim, even combined with spacers. Be careful when removing and reinstalling fender shims during car repairs or modifications. Key points. Multiple shims. Some bolts might have multiple shims stacked on top of each other. Shims with spacers. In some cases, shims might be combined with spacers for precise alignment. Why it matters. Proper alignment. Shims play a crucial role in aligning body panels like fenders. Incorrectly reinstalling them can lead to gaps, misalignment, and poor fit. Reassembly. Keeping track of the original shim configuration is essential for reassembling the car correctly. Here we have a 68 Camaro with a 238 straight 6 engine, power steering, electronic, cruise control, second owner. Let's talk about sandblasting this car. Of the firewall, the front frame rails, engine cradle, bumper brackets, radiator support, transmission tunnel. It's important to plug holes to prevent sand entering the passenger compartment. And after sandblasting, wipe down and remove any grease or sand residue. Here I do a slight price comparison. Chassis shield versus port 15. Summit Racing chassis shield is $36.99 a quart. Port 15, 45404 rust preventative coating, semi-gloss black is $41.48 a quart. Let's talk about Summit Racing chassis shield. Durable, high-grade epoxy paint that sticks to bare metal, providing protection against peeling, cracking, and scratching. Rust prevention contains rust inhibitors that prevent future corrosion, especially important for underbody areas exposed to the elements. Chemical resistance to road salt, gasoline, and other chemicals like transmission fluid, making it ideal for protecting the car's underbody from harsh weather. This is the donor motor, a PPV L77 with AFM, which is the active fuel management, which will not be used. The oil pump was replaced with a standard oil pump. This is recommended. It's also recommended to plug the pressure relief valve in the oil pan if it has one. External oil cooler was deleted on this engine, and this is a non-VVT engine. Some variables on this engine: fuel injector types. LS1 is the EV1, LS2 the EV6, LS3 the EV6 with 42 pounds of pressure. That's what this engine had. We got the intake manifold map sensor type. It comes either with a Delphi map sensor or a Bosch. This motor came with a Bosch map sensor. Again, in reference to the front sheet metal, remove it to avoid damage and improve access. Use teamwork. The front clip is heavy. And of course, remove the tires first. Use WD-40 sparingly to free up parts without ruining paint or anything else. Age affects bolts. Rust can cause them to seize and break during removal. Half-inch front subframe bolts may need to be cut, and always bag and tag. Another reminder: avoid injury and car damage. 4 people for the radiator support is ideal. Prevent snags and hang-ups. Be patient and methodical. Again, take your time. Remove all bolts and fasteners to avoid frustration. Remove important components like the front wiring, ground wires, and hoses. The stock body mounts, it's a good idea to replace them. A lot of people recommend the solid aluminum mounts. The front sheet metal clip, you want to remove it, clean it, prep it, paint it, and reinstall it carefully. Okay, let's talk about the stock subframe, F-body generations, first or second. To keep the stock subframe, special engine mount adapters are needed. You're going to need a transmission crossmember because a new location is needed. Specifically designed exhaust headers are required. Always use grade 8 bolts when you can, and the sliding ability is helpful on engine mounts. Say some guys, other guys say static engine mounts from Detroit Speed are best. Let's talk about wire splicing. When choosing an aftermarket harness, choose a company that utilizes ultrasonic wire welding. Regular soldering is no longer accepted by automotive manufacturers, and ultrasonic wire welding is superior to clip and dip. Some guys like Mass Motorsports. They say it's the most advanced harness in the industry, the M90 ECM computer. They provide stuff like marine grade TXL wire, like we mentioned, ultrasonic welds. It comes complete. Their kits come complete with a fuse box, relay box. And as a side note, Mass Motorsports was a pioneer in controlling variable valve timing engines, VVT. As mentioned before, carefully remove your wire harness before installing your new engine. You want to prevent damage to the harness. Now, if your wiring harness is in good shape, which that's rare, you can send it out to get it professionally inspected and labeled. Now, if you're going to purchase a new chassis wiring harness, you need to plan ahead. Make sure the length of the kit is long enough for the ECM placement, the fuse block placement, and the OBD2 port placement. This is important. Hopefully when you purchase the wire harness, the company that you're purchasing the harness from will ask you how much extra length you need. So again, you want to give yourself some slack when figuring out where you're going to put the computer. You may want to mock up a cardboard box. Place it under the glove box, maybe behind the glove box. Remember, the devil is in the details. When installing the OBD2 port connection, you need to meet the federal standards. Okay, make sure the connector has a 16-pin J1962 connector, and it's installed according to federal standards. A lot of people choose the glove box because it looks clean. Now let's talk about the reluctor wheel on the crankshaft. You got two options with LS engines: the 24-tooth Gen 3 engines and the 58-tooth Gen 4 engines. Needless to say, the reluctor wheel is important because it determines your ignition timing. You're going to need to know this because when you purchase the wiring harness, you'll need to provide this information. In this case, we use the 50-tooth reluctor wheel. I would be wary of a company selling you a wire harness that doesn't ask you this question. Okay, here we're looking at some key components. The reluctor wheel mounted on the crankshaft. It has 58 teeth with one or more teeth offset, and a sensor, a magnetic pickup that uses the Hall effect. It detects the passing teeth on the reluctor wheel. Its function, the sensor sends fluctuating signals to the engine control unit, the ECU, indicating the crankshaft's position and rotation speed. This information is crucial for precise timing of fuel injection and ignition events. Okay, let's spend some time to talk about the duties of the crank cam position sensor in the engine. Primary function is to report engine speed. The sensor measures how fast the crankshaft is rotating. This information is crucial for the engine control unit, the computer, to determine how much fuel and air to deliver. Give rotational position. The sensor tracks the exact position of the crankshaft at any given moment. This allows the computer to precisely time the ignition spark, ensuring it occurs at the correct moment in the engine cycle. We kind of talked about this earlier. Now the synchronization. The ECU uses the information from the crank cam position sensor to synchronize two critical aspects of engine operation. 1. Fuel pulse. The ECU uses the sensor data to determine the precise timing of fuel injection. This ensures that all fuel is delivered to the cylinders at the optimal moment for combustion. 2. Spark. The sensor data allows the ECU to precisely time the spark plug firing. This ensures the spark occurs at the correct moment to ignite the air-fuel mixture efficiently. Location of missing or extra tooth. The crankshaft often has a missing or extra tooth on the reluctor wheel. This key allows the ECU to accurately determine the top dead center of the piston stroke, which is essential for precise engine timing. Alright, in summary, the crank cam position sensor plays a vital role in the engine's operation by providing information about engine speed and position, which the ECU uses to control fuel injection and ignition timing for optimal performance. Okay, let's talk about spark plug types. Copper, least expensive, shortest lifespan. Platinum, more expensive than copper, longer lifespan than copper, better performance than copper. Iridium, these are the most expensive, longest lifespan, superior metal, best performance. Now if your owner's manual calls for iridium, then you got to use iridium. Downgrading to platinum plugs might not be ideal. Automotive wiring is complex. Some people even compare it to calculus in terms of difficulty. Learning is key. It's essential to learn about automotive wiring to troubleshoot electrical problems. Figure out why the car lights won't turn on or why your radio is acting up. Now, install aftermarket electronics. This adds new features like stereo alarm systems or GPS without causing damage or safety issues. Do these tasks safely. Working with car wiring involves electricity, so it's crucial to do it safely to avoid shocks or fires. Understanding automotive wiring is a valuable skill that can help you maintain your car, troubleshoot issues, and safely add new features. These are the basics of automotive wiring. The electrical systems in most cars have a 12-volt battery system where the negative terminal is grounded to the car's chassis. Here are some benefits of using the Anderson connector in automotive wiring. Practicality. High current. Anderson connectors are designed to handle significant electrical loads. Quick disconnect. They allow for easy and rapid connection and disconnection of electrical circuits. 2-inch pin ferrules. Dual crimping. The design accommodates 2 crimps on the pin, ensuring a secure and reliable connection. In essence, the Anderson connectors offer a practical solution for automotive wiring applications that require high current capacity and the ability to quickly connect and disconnect circuits. Basic tools needed for working with AWG wire size 8 and larger. These tools are essential for tasks like crimping connectors, soldering connections, and preparing the wire for installation. Here's the list. Crimper, used to securely attach connectors to the wire. Cutter, used to cut the wire to the desired length. Map torch, used for heating the wire and soldering. Solder during soldering. Bench vise, used to hold the wire securely in place while working on it. And your solder. Remember, using the right tools is crucial for working with large gauge wires to ensure safe and reliable connections. Next is barrier strips in automotive wiring. Here's a breakdown. What are barrier strips? They're a common component in automotive electrical systems. Where are they found? Barrier strips are used in many places within a vehicle, helping to organize and distribute electrical signals. What's the purpose? They provide a way to connect multiple wires together in a neat and organized manner, often used for things like lighting systems, accessories, and other electrical components. The fork connector is a type of terminal often used with barrier strips. In summary, barrier strips are essential for maintaining a clean and organized electrical system in a vehicle. Here we see Molex connectors. Here's a breakdown. Molex connectors, often referred to as the Coca-Cola of connectors, they are a very popular and widely used type of connector in various industries, including automotive. Key features. Molex connectors are known for their reliability, durability, and ease of use. They come in a wide variety of sizes and configurations to suit different applications. In summary, Molex connectors are a common and versatile choice for connecting electrical components in automobile and other industries. Next up, GM WeatherPack connectors. What are GM WeatherPack connectors? They're a type of electrical connector commonly used in general motor vehicles. They are designed to be weatherproof and resistant to moisture and vibration. These connectors are known for their reliability and durability. Key features: seal design, protects the electrical contacts from the elements. Ease of use. They're relatively easy to assemble and disassemble. Widely available. Parts and accessories for GM WeatherPack connectors are readily available. GM WeatherPack connectors are a popular choice in automotive wiring due to their robust design and reliability in various environmental conditions. Next, Dutch connectors. What are they? They're a type of high-quality electrical connector known for their reliability, durability, and performance. They are commonly used in demanding applications like automotive, aerospace, and military. Key features: rugged construction. These connectors are designed to withstand harsh environments, including extreme temperatures, moisture, vibration, and shock. Waterproof and dustproof. They provide excellent sealing to protect the electrical contacts from the elements. High current capacity. They can handle high electrical currents, making them suitable for demanding applications. Wide variety. These connectors come in a wide range of sizes, configurations, and materials to suit various needs. Deutsch connectors are a premium choice for automotive wiring applications where reliability and performance are critical. Okay, let's talk about the different positions of the ignition switch in a typical car. Here's the breakdown. Ignition switch positions: off. As the name suggests, this is the position where the key is removed and the car's electrical system is completely shut down. On/ACC accessory. In this position, some electrical accessories like the radio, power windows, and interior lights can be used even without the engine running. Then we got on/ACC and ignition. This is the position where the engine can be started. It powers the ignition system, fuel pump, and other components necessary for starting the engine. Some accessories also remain active in this position. The start position. This position is used to crank the engine. Once the engine starts, the switch automatically returns to the on/ACC and IGN position. The ignition switch controls the flow of power to different electrical circuits in the car depending on the position. In automotive wiring. Here's a breakdown. Key points. Low voltage, low risk. While automotive systems use high current, the voltage is relatively low, usually around 12 volts. This means the risk of electrical shock is significantly lower compared to higher voltage systems like your home, for example. Automotive amps are high. Current amperage used in automotive system is much higher though than the typical 15 amps found in household circuits. This high current is necessary to power various components like the starter motor, headlights, and other electrical systems. In summary, automotive wiring systems operate at low voltage, 12 volts, to minimize the risk of electrical shock. However, they utilize high current to power the various electrical components of the vehicle. Now let's talk a little bit about the conservation of energy and its relevance to understanding automotive wiring. Conservation of energy. Energy cannot be created or destroyed. This fundamental principle states that energy can only be transformed from one form to another. For example, electrical energy can be converted into heat, light, or mechanical energy. Understanding automotive electronics. Ohm's law and Kirchhoff's law. These are fundamental laws of electricity that describe the relationship between voltage, current, and resistance in electrical circuits. Understanding these laws is crucial for grasping the basics of automotive electronics. Conservation of energy is a key concept in understanding how electrical systems work in vehicles. By applying this principle and understanding laws like Ohm's law and Kirchhoff's law, you can gain a better grasp of automotive electronics. Now let's talk a little about Ohm's law, a fundamental principle in electronics. Here's the breakdown. Ohm's law, foundation of electronics. It's a core concept that describes the relationship between voltage, current, and resistance in an electrical circuit. Voltage, which is V, represented by V, difference in potential. Voltage represents the electrical potential difference between 2 points of the circuit. Measurement in volts. The unit for voltage is in the volt, V, often expressed as E in mathematical formulas. Voltage is often represented by the symbol E. Okay. A visual representation of Ohm's law is here in the slide in the form of a wheel, which shows the relationship between voltage, current, resistance, and power. The key formula in Ohm's law is V equals I times R. Okay, V is voltage, I is current in amps, R is resistance in ohms. This formula shows that voltage is directly proportional to current and resistance. Okay, now let's talk about automotive wiring schematics. Here's a breakdown. Schematics, wiring diagram, a visual representation of the electrical connection in a vehicle. Connections. Simplified drawing, a simplified version of a wiring diagram, often used for easier understanding. Components and standardized symbols, a list of common components found in automotive wiring diagrams and their corresponding standardized symbols. These include ground, represented by a triangle or a line connected to the ground symbol. Lamp or light, represented by a circle or a circle with a filament. Inductor, represented by a coil symbol, can represent various devices like pumps, motors, or speakers. Relay, represented by a symbol with a coil and contacts. Resistor, represented by a zigzag line. Diode, represented by a triangle with a line. Light emitting diode, LED, is represented by a triangle with an arrow. Motor, represented by a circle with lines representing the armature and the field coils. Fusible link, represented by a wavy line. Connections and disconnections. Two lines crossing at 90 degrees indicates no connection between the circuits. Two lines crossing with a dot indicates a connection between the circuits. Broken line represents a broken connection in the circuit. Switches. Single pole, single throw, SPST switch, show in open and closed positions. Single pole, double throw, SPDT switch, shown with common, normally closed, and normally open contacts. Understanding these symbols and conventions is crucial for interpreting and working with automotive diagrams. Next, let's talk about combinations of electrical formulas to troubleshoot problems in automotive wiring. Key point: hybrid formulas. Sometimes a single formula like Ohm's law, V equals I times R, might not be sufficient to solve a problem. In such cases, it may be necessary to use a combination of formulas or rearrange them to find the desired solution. Example: P equals E squared divided by R, which is the combination of Ohm's law and the power formula, P equals V times I. This formula can be useful in situations where you need to calculate power given voltage, E, which is your current, and resistance, which is R. It's important to be flexible and adaptable when troubleshooting electrical systems. Sometimes it requires combining or modifying existing formulas to find a solution. Remember, improvise, adapt, and overcome. Okay, next let's talk about Kirchhoff's voltage law in the context of automotive wiring. Kirchhoff's voltage law, KVL. What is it? KVL states that in any closed loop within an electrical circuit, the sum of the voltage drops across each component is equal to the total voltage applied to the loop. How is it relevant to LS swaps? Well, LS swaps often involve modifying or adding electrical components in a vehicle's wiring system. KVL is crucial for understanding how voltage is distributed throughout the modified circuit. By applying KVL, you can ensure that the voltage drops across each component are within acceptable limits and that the total voltage applied to the circuit is properly distributed. In summary, KVL is a fundamental principle in electrical engineering, and understanding its application is essential for troubleshooting and modifying electrical systems in vehicles, especially during complex projects like an LS swap. So go ahead and Google it, learn more about Kirchhoff's voltage law and its implications for your LS swap project. Next, let's talk about Kirchhoff's current law, or law on current, in the context of automotive wiring. Kirchhoff's current law, KCL, what is it? KCL states that any junction node in an electrical circuit, the sum of the currents flowing into that junction must be equal to the sum of the currents flowing out of the junction. In simpler terms, imagine water flowing through pipes. At any point where the pipes join or split, the total amount of water entering that point must equal the total amount of water leaving that point. How does it relevant to automotive wiring? KCL helps in understanding how current flows through the various branches of a circuit in a vehicle. It's essential for analyzing complex circuits and troubleshooting electrical problems. KCL with a simple circuit. 4 amps of current enter the junction. Okay, referring to the image on the slide. This current is then divided into 4 equal branches with 1 amp flowing through each branch. 1 amp. The total current leaving the junction is also 4 amps, which is equal to the current entering the junction. In summary, KCL is a fundamental law in electrical engineering that helps analyze current flow in circuits. Understanding KCL is valuable for anyone working with automotive wiring systems. Let's talk about the concepts of series parallel circuits in automotive wiring. Series parallel circuits. Combination. These circuits combine elements connected in series with elements connected in parallel. How the laws govern them. Ohm's law and Kirchhoff's laws. To analyze and understand the behavior of series parallel circuits, you need to apply both Ohm's law, which relates to voltage, current, and resistance, and Kirchhoff's law, which govern current and voltage relationships in circuits. In summary, series parallel circuits are more complex than simple series or parallel circuits. Understanding how Ohm's law and Kirchhoff's law apply in these configurations is crucial for analyzing and troubleshooting electrical systems in vehicles. Okay, series circuits in context of automotive wiring. Series circuit. Connected end to end. In a series circuit, all components like lights, resistors, etc. are connected one after the other, forming a single continuous path for the current to flow. It's like a chain. Each link depends on the others. Circuit dependencies. If one component in a series circuit fails, for example, a light bulb burns out, the entire circuit is broken and no current can flow. through any of the components. Series circuits are a basic type of